So what about something like this? But let's start off, let's just make sure, and I know that sometimes this just gets glossed over, but let's really make sure we understand what this is asking. The terminology is important. And I don't do a lot of, maybe I should do more of this where I give you vocab sheets and stuff. And I feel like if you just, if you just go through this stuff in class and you really focus, I think you'll get all the necessary vocab and you'll understand the terminology just from that. I don't think I have to do really a whole lot extra. You tell me if I'm wrong, but what about a problem like this where it says use factoring in the zero product property to find all real zeros of the function? So what is a zero? And the word zero is really key here.
Where they intersect the zero.
Okay, well yeah, it's where the y value is zero, where the function is zero. So when we want to find the zeros are the places, meaning the x values, right? Where the function has a value of zero, meaning, and that really those are just x-intercepts, aren't they? Right? Does that make sense? So we're going to find the zeros. That just means that we are setting the function equal to zero. We're setting f of x, which is y, equal to zero. Okay? So we're going to turn this into an equation, right? That's the first step. Once we have an equation, we have something that we can work on. Now we can try to solve this. Okay, they're telling us specifically in this problem to use factoring and the zero product property. Now think about what factoring means. I know it's something that we just kind of jump in and do, but what is it really? I mean, what are we trying to do? If I'm trying to factor this trinomial, I've got this quadratic expression here in the form ax squared plus bx plus c equals 0, right? So this is a quadratic equation in standard form, right? Set equal to 0. So what are we trying to do when we factor? Think about this as a strategy. And that's something I really want you guys to think about, own this idea of developing strategies, because that's what math is becoming. Math has always been, math evolves. It gets to be, I realized there was a time when math was pretty cut and dry and pretty simple. You just kind of repeated what you were just shown and practiced some simple algorithms. But the further you go in math, the more strategic it gets. I think I've probably told you this before, but in calculus, I would say 90% of the calculus that we do is not being able to just do the calculus. The calculus itself isn't that hard. What's hard is coming up with a way to use the calculus strategically. Because you can take a wrong turn in calculus and just go down an infinite road where you never get to the answer. Or if you're smart about it, you can get to the answer pretty quickly. And we're kind of turning that corner a little bit in Algebra 2 now. And we're going to see that throughout the rest of this semester. As we look at different ways to solve quadratic equations, the very first thing we're always going to do is look at this and say, okay, well, now what's my approach? What do I try first? What's plan A and what's plan B? And you really got to think about it that way. So plan A is what we're practicing right now. The first approach we have is to factor if it works and it's convenient. What does factoring mean? We're trying to find the values of x that make this equation work, right? But think about what we've always done, prior to this unit, right? I'm just doing a little review here. We've always been able to point at a single value of x and say, aha, there's a single x, so I can isolate it, but I can't this time, right? Because I've got x squareds and x's, so I can't isolate x. So I have to do something different. I have to factor it and use the zero product property. What does that mean? Factors are what in math? Things that are what? Say it again? Yeah. Multiply. Yeah, if I said, what are the factors of 6, you'd tell me 2 and 3, right? Because those are what multiply to make 6. So when we're factoring something, we're trying to break it into a product of factors. Like if we factor 6, we turn it into 2 times 3, right? So if we're going to factor this expression, we're trying to turn that into something like 2 times 3, right? It's not going to be 2 and 3. But we're going to break it into the product of something times something, right? And that's kind of the skill, that's the big skill that we're working on in this part of the unit. So talk me through that part. If I'm going to factor something like this, what are the values of A, B, and C? What are A, B, and C here for our quadratic expression? What's that mean? Come on now, I know you guys know this. If I'm writing this in quadratic equation in standard form, if it's a quadratic equation in standard form, it's just in the form ax squared plus bx plus c equals 0, right? Remember standard form. So what's A? 1. Yeah, what's B? So what is it again? -1. What's C? There you go. Okay, so we know what they are, right? A is 1, B is -1, C is -42. But most importantly for now, A is 1. That's something you always like to see. When A is 1, that makes life really simple. Okay? When A is 1, then when we split this apart into factors, when we draw our template, what's the first thing we do? We make our brackets, eventually this may not work, but we're at least going to try, right? Because this is easy when it does work. So I make my brackets for the two factors. What else can I write? If A is equal to 1, what goes there and there? Say it again? X, yeah. Okay, now I want you to think why that is, right? Because factoring means we're breaking something apart. Let's use the example like we just talked about. Let's use the example of factors of 6, right? If I break 6 up into 2 times 3, that process is called factoring. Well, what if I multiply the factors together? What am I going to get? 6. So the reverse process, going from there back up to 6, we could call multiplying. And that would make sense. In math, a lot of times we'll call it expanding. And that makes more sense when we're talking about variables and numbers. But I factor to get to here. If I want to multiply these two factors together, what am I going to have to get back? That thing, right? Yeah. But I have to get that, right? Because this is what I broke apart into a product of factors. If I multiply them back together, I just reverse the factoring process and undo it, right? You get the idea of what factoring means then? We're breaking it apart. Later on, when we're dealing with big polynomials, we'll go back and practice how we multiply factors together to make bigger polynomials. It's not hard. That's a pretty easy process. Factoring's a little trickier. But what's the only way I'm going to get an x squared? If I have an x times an x, right? So that's why those have to be x's. So the question is just then, can we get the magic numbers, right? That's my goal, is to get the magic numbers. And if they exist, factoring is really simple and easy. If they don't exist, we'll have to go to plan B, which we don't know yet. But that's coming up, right? That's next unit. Okay, so what do the magic numbers have to do here? Let's focus on those magic numbers. So we call them N1 and N2, right? N1 times N2 has to equal what? -42, yeah. Has to equal C. And actually what it has to equal is A times C, but A is 1 in this case, so we just say C, right? So it has to equal -42, and what does N1 plus N2 have to equal?
1.
Not 1, -1, has to equal B, good, right? And so we're just going to try to find those magic numbers that multiply to -42 and add to -1. What do you think? -7 and 6, yeah, good. We know they'd have to be opposite in sign, right? Because they multiply to a negative. And if the negative is, if they add to a negative, the negative is bigger. And you could even be tricky and say, how much bigger is it? Well, it's got to be 1 bigger. Because when I add them up, they almost cancel, but there's 1 negative left over. So that's a good way to look at it, right? So we end up with x minus 7 and x plus 6. So now it's factored. And this is where the zero product property comes in, right? Zero product property. Remember what that says. The only way I can multiply stuff and have it equal 0 is when I do what? If I multiply 11 times some mystery number and I get back 0. Well, what's the mystery number? 0, right? The only way you can get a product equal to 0 is when one of the factors is 0, right? So what are the only ways this could happen then? Well, either this factor has to be 0 or that factor has to be 0. So we just have to ask ourselves, now those are easy equations to solve. If I want to know when x minus 7 equals 0, well now in that little equation I do have a single x that I can point to and isolate, right? And I don't even have to probably write it down, we can just do it in our head. What's the value of x that's going to make that factor 0? 7, yeah. So x equals 7, or what's the value that makes that factor 0? Negative 6. Yeah, I know that's probably, that might be a little overkill for review, but I want to just make sure we're all, I mean, it's been a couple weeks, right? So those are our two solutions. How could I check it?
Plug it in.
Plug it in. See if I get 0 when I plug them in. Okay? All right, so this looks different, but this is actually much easier. But I want to make sure you guys understand that this is easier. Okay? What if, now, notice what this is asking me to do. Easier question. All this is asking me to do is just factor the expression. That's it. It doesn't ask me to solve anything. It just wants me to rewrite that in factored form. So I'm going to write it as a product of factors. Like 6, we would write as 2 times 3, right? So that's all I've got to do. Now, how many terms are there here? 2, right?
Yep.
There's only 2 this time. So it makes it easier. The factoring process when there's 2 terms is dead simple. You don't have to do any of the magic numbers or anything. The only thing you could possibly do with 2 terms is just factor out a greatest common factor. That's it, right? So is there a greatest common factor? What's the biggest? We had to look for the number part and the variable part. The greatest common factor is everything I could undistribute, right? So Tyler, what's the number part? What's the biggest number that divides into both 9 and 27? And it could be one of those numbers even. What?
9.
Oh, 9. Does that make sense? 9 divides into both, so we can pull a 9 out front. And then, what about the variables? Could I undistribute a variable there? I could undistribute an x, couldn't I? Right? Because both of them have at least x to the 1, right? So if I undistribute those, Aiden, what's going to be left over? Now you can think about this, remember, when I undistribute, I'm just dividing each term by 9x. And so I could just say, well, what is 9x squared divided by 9x? And whatever I get goes there. And I could say, what's 27x divided by 9x? And whatever I get goes there. But to me, the easiest way is just to think backwards. 9x times what is 9x squared? 9x to the 1 times what is 9x to the 2? X. Yeah, not 9x, just x, right? We already have the 9. We just need an x squared. See what I'm saying? 9x times what is 27x? 3, yeah. Done. That's it. That's it. So this is what we'd call out front, the greatest common factor. And I just call this the remaining factor or the leftover factor. You know, it's not technically called that, but that's how I always refer to it. But our answer that we put in Moodle is just that. Okay? Okay, how about something like this? Once again, we're just asked to factor it. So what do we think here? All we're doing is factoring. What's the first thing we always want to try to do?
Find the
Greatest common factor. You got it. Let's see, Shanna, is there going to be a greatest common factor here? Is there a number that divides into 10 and 17 and 6?
No.
No, 17 is prime, right? So there's no number that's going to go into all those. Can I undistribute a variable?
Yeah.
Are you sure?
No.
How come I can't undistribute a variable? Yeah, there's no x with the 6, right? So there is no greatest common factor other than 1, and that doesn't help us a bit, right? So we're stuck with this the way it is, but we're still trying to factor this. And now the instructions here are, you know, maybe in the real world, if we were trying to solve an equation, like find the zeros of that, because a is not equal to 1, maybe we don't even want to bother factoring, and we just go to plan B, which we don't have yet. But this time, I'm asking you to factor. I'm telling you, I want you to factor this thing. And so we have to try to break this down into factors. okay? So what do? If we've got a situation like this where A is equal to what? In this case? No. What's A? A, B, and C are it's 10, they're the coefficients, right? So A is 10, what's B?
17.
And what's C?
6.
So this time, A is not equal to 1, right? So if we're trying to factor a quadratic trinomial, 3 terms, x squared in it, right? So it's quadratic trinomial, and A is not equal to 1, what's our strategy called for that? What do we call that trick that we use? What? Bottoms up. Yeah, that means bottoms up, right? If A is not equal to 1, then we know right away if we're going to factor this, we got to use bottoms up, right? Okay, so let's go through the bottoms up process. How does that work? So we got to find magic numbers. The magic numbers have to multiply to what? Do you remember?
6.
What is it? Not 6, not just 6.
17.
They're going to multiply to the product of A times C. So what is A times C? We'll do this time. What is it? 60. Yeah. 10 times 6 is 60. What's B? Well, we already told me it's 17. So my magic numbers then, N1 times N2 has to equal 60. And just like before, N1 plus N2 has to equal 17, right? So we'll just make a table, right? And I do think the tables, if you kind of get stuck with these, and sometimes the numbers get big, just make the table. In fact, everybody write this table down as we do this, just so you've done it at least once. Maybe you have in the past, but we'll do it again here real quick. So we got a column for the first magic number, we got a column for the second magic number, and we got a column for the sum, right? And we're going to pick, the magic numbers have to be factors of 60, but what are the signs going to be? Now think about the signs. If they multiply to a positive and add to a positive, the signs are positive, yeah. So we could do 1 times 60, but that adds up to 61, which is way too big, right? So the numbers are too far apart. So we can work our way down, right? Maybe we want to skip the 2 and just go right to the 3. 3 times 20 would be 60, and that adds up to 23. We're getting closer, right? What would be next? 4 times 15 would add up to 19. Boy, we're almost there. What's going to be? 5 times 12 adds up to 17. So those are the magic numbers, right? Okay, so step 1 of bottoms up. Step 1, remember, and let's just go through this as a group. I know you guys have probably done this a million times in the past, but step 1, we're going to set up a template just like we normally would, with x's in the beginning, right? And we're going to combine the magic numbers with the x's, just like before. But what's the one key difference? There's one really important difference. What do we have to do to the magic numbers? We have to divide them by what?
10.
10, yep. We divide them by 10, whatever A is, right? Okay, makes sense? What's the next step in bottoms up?
Solve the
What looks goofy about those fractions that we created?
We can simplify.
We can simplify them. We can reduce the fractions, couldn't we? So step 2 is we're going to reduce or simplify the fractions, whatever you want to call it. So this becomes x plus 1/2 times x plus, what's 12/10 reduced to? 6/5, good. And then the last step is just to go bottoms up. And that's the one where if there's a number left in the bottom of the fraction, if there's a denominator, then that goes up in front of the x, right? Like so. So we end up with 2x plus 1 times 5x plus 6. Okay, so we factored it. How could we check our work here?
You could plug the 10 in. Just kidding. I don't know.
Well, you're actually on to something. It doesn't have to be the 10. I mean, how would we have checked that we factored 6 correctly into 2 times 3?
Times them.
Just multiply them and see if we get 6, right? So how could I check that this is correct?
Oh, sorry.
I could just multiply this out by distributing, right? And if I did that, what would I need to get?
10x. Yep.
That, right? If I multiply it out. Okay, here's another great trick. Really good trick that you can use on SATs or whenever you're asked to do a problem where you're not solving, where it says write it in factored form. So you're factoring something or you're simplifying something, where you're just taking some expression and you're writing it in a different way, right? Like in this case, the function is the same quadratic function, but we've changed it from standard form into factored form. But they're the same, right? They're supposed to be the same. So what would happen if I plugged a random value of x in and figured out what the value of the function was if I plug in like 17? If I plug it in there and I get some number, what's going to happen if I plug it in here? If I did my work correctly. Should get the same number, right? Isn't that a great trick? Just pick some random number on your calculator and plug it in here, get a number, write it down, and then take the same number and plug it in here for x and see what you get when you multiply it out. And if you get the same number, you probably did it right, right? It's a really quick and easy way to check. Okay. Okay, what about something like this? I picked each of these problems for a reason, because I want to show you something. There's an issue you're going to grapple with when you're doing these problems. So there's something a little different with this one. This is one where we're trying to find the zeros, right? So we're going to take this function and we're going to set it equal to 0, right, and solve. Okay, so there's step number 1. We set up an equation. Okay, we're going to solve by factoring, so we want to see if there's a greatest common factor. Is there one?
No.
There isn't. The only common factor that we could pull out of this would be -1, right? We could factor out a -1, which would be helpful. But instead of thinking about it that way, I'm just going to tell you something that I'm not even going to justify this. I'm just going to tell you this, and you're going to believe me for now, because this will help a ton. Whenever you write a quadratic equation in standard form, all quadratic, I can't spell. Standard form should have, gosh, I really can't spell. All quadratic equations in standard form need to have a positive value of a. Well, what's the value of a right now?
-4.
-4. Okay, well, what would I do to an equation if I want to change the sign of that term?
Times it by negative.
Yeah, I'm going to times both sides, right? Because if I have an equation, I have to treat both sides equally, right? I'll just multiply each side by -1. What's 0 times -1? So it's easy, right? When you have standard form equations, I can multiply both sides by whatever I want to, and I'm still going to end up with a 0, right? So if I multiply each side here by -1, I just end up with what? Just changes all the signs, doesn't it? So now I get positive 4x squared plus 19x plus 12 equals 0, right? Okay, everybody see that? And now I could go move forward just like I did before. I would just factor this using bottoms up. Okay, I'm going to skip ahead a little bit. There's one I want to do. Kind of want to do this one. Yeah, let's do this one. Okay, very similar. So once again, we're going to find the real zeros. We're going to set this thing equal to 0. Okay, now if I were asked to factor this completely, I would need to write the list of factors, what's equal to 0, would have to include any greatest common factors. So let's go ahead and just, let's find a greatest common factor here. Is there one? I can't
No.
undistribute a variable, but is there a number that divides into all those?
No, because 2 is, no, actually, no.
3 does. How'd you know, Derek? You're using the trick, aren't you? If you add the digits up, if you add the digits of the number up, if you get a number that's divisible by 3, then the big number is divisible by 3, right?
Sure.
So 2 plus 1 is that, well, maybe, I was giving you the benefit of the doubt there.
Yeah.
So 2 plus 1 is 3, which is divisible by 3. 7 plus 8 is 15, which is divisible by 3. So we know 3 goes into all those, right? Okay, so I could factor out a 3. If I factor out a 3, what am I going to be left with?
X.
Let me do. I'm going to be left with what? 3 times what is 15x squared? 5x.
5x.
X squared, right? 3 times 5x squared would be 15x squared. 3 times what is negative 201? Well, I can just divide 201x by 3. What am I going to get? 67? And then 3 times what is 78? That can be 26. Okay? And then all that is equal to 0, right? Okay, so then if I wanted to, I could keep going with this, right? Now I could take everything in the yellow and factor that out, couldn't I? Right? And if I do that, I'm hopefully going to end up with something like this. 2 yellow factors and the 3 out front, right? Okay, but if I apply the zero product property here, so I'm going to get something like down here, I'm going to end up with some factors that I could set equal to 0 to find values of x, to find solutions, right? Does the 3 ever equal 0? It never does, right? That's not going to give me a solution because it's a constant. There's no x there, right? Does that make sense? So if I'm just trying to solve this thing, if the question asks me to write it in factored form, then I would have to include the 3 because my answer, if I multiplied it out, would have to give me the original expression. But that's not what's being asked. We're just being asked to solve the equation. So that 3 isn't going to help us ever, is it? So why not get rid of it? Why not divide each side through by 3 and get rid of it? You see that? Right? So right here I could just say, well, we'll just divide each side through by 3. Right? And cancel it. 0 divided by 3 is just 0, right? In fact, if I knew that 3 went into the left side, up here at the very beginning, I could have just divided each side through by 3, right? I can divide both sides of an equation by any number I want to. Now, I can't divide by variables. I'm going to lose solutions and change things then. But if I have an equation, as long as I treat both sides equally, I'm fine. So I could have just divided 3 through both sides and gotten right down to the simpler equation, 5x squared minus 67x plus 26 equals 0, right? You take your pick, whichever way you want to think about it. They both work equally well. Okay, no matter which way we do it, though, what's that? Either way you slice it, we get down to here. We get down to 5x squared minus 67x plus 26 equals 0. So now our goal is we've got to factor that. So what are the values? What's AC? It's 5 times 26.
130.
Yeah, 130. What's B?
60, negative 60.
So I gotta find magic numbers that multiply to 130 and add to negative 67, right? So what's that tell me if they multiply to a positive and add to a negative? What's that tell me about the signs?
They're one positive and one.
If they multiply to a positive,
Oh, I'm just kidding. They're both.
multiply to a positive and add to a negative. Both negative, yeah. So we can make our little table here. And see what we get. So I could do negative 1 times negative 130, but that's obviously way too big. Let's see, that's 130 is even, so I could do negative 2 times negative 65. What do you know? That's it, isn't it? Right? I get that adds to negative 67. So that's it. Okay, so now let's go through bottoms up. I want to show you something important here that happens with bottoms up. So step 1, we're going to set up our normal template, right? It's all equal to 0, remember. We got 0 on the right side always. And what do I do with my magic numbers here?
You divide them by 5.
I got to divide them by 5, don't I? Good. And I got to divide these all by 5. Okay, step 2.
If there's a denominator, I'll simplify.
Simplify. So I get x minus 2/5 times x minus 13. Okay? Now think about this. Here's the part, here's what I wanted to show you on this one. With bottoms up, technically, if I want to factor this thing, I have to go bottoms up and make that a 5x minus 2, right? But all I'm trying to do is find the zeros. I'm going to be making my life harder if I do that, because what's the 0? You tell me right now. This is easy for you. What's the 0 of that factor? 13. That factor equals 0 when x equals 13. What's the 0 of that factor? 2/5. Look how easy it is. What minus 2/5 is 0? 2/5. So there's no need, if you're trying to solve an equation by using bottoms up, you don't even do the last step. It's just, because look what would happen if I did the last step. It would just make our lives harder, right? If I did the last step and I made this 5x minus 2 times x minus 13 equals 0, then, yeah, this one's pretty obvious, but finding the 0 of this one, I'd actually have to do some math, right, to find out that it's 2/5, whereas right here it's obvious. So we'll just skip that whole step, right? See what I'm saying? Okay? I think that sums it up pretty well. Does that help? Go through that a little bit? Okay, so I can't emphasize this enough. We still have a little bit of time, but do not, I mean, if you're behind, oh, I'll throw you another little opportunity on this. I'm going to put up short review assignments for each of the tests. Now, here's what I'll let you do. If you are missing some assignments, I'm going to give you an opportunity to get out of jail free here. And if you have done some, then this will just replace your lowest score. What I'm going to do is I'm going to say that I'm going to make the review assignments worth double credit, but if you do the review assignment, then I will drop your lowest grade. Now, if you don't do the review, you know, you got to do the review, but I'll make them short. Okay, does that make sense? What I'll do in the grade book is I'll make the reviews, I'll give you 2 grades for the review. One of the review grades you could drop. So it'll only be worth a single. If you don't do it, you're only missing a single assignment. But if you do the reviews, then I'll fill in both columns in the grade book, and I'll add one in the grade book. I can have the option of dropping your lowest grades. For each one of the reviews, I'll drop an additional homework grade, right? So for the 4 reviews, if you do all 4 of those, by doing all 4 of those, I'll go back and fill in 4 of your homework grades with, you know, they'll be excused. Does that make sense? That's a pretty good deal, don't you think? Yeah. That's a great deal.